Hello, in this lecture I will answer two questions. In the first question, we'll find out the perimeter of this quadrilateral ABCD. And in the second question, we'll find out the area of this green shape. So we'll start with the first question. In the drawing, we have quadrilateral ABCD. This is line segment BQ, that is equals to 10 units in its length. This is line segment QP, that is equals to 20 units in its length. In addition, we know that AP equals to PD. This is line segment QC, that is equals to 40 units in its length. Those three angles are all right angles. Again, our task is to find out the perimeter of this quadrilateral ABCD. So, what is the perimeter? The perimeter of a quadrilateral is the sum of its four side lengths. In this case, it is equals to AB plus BC plus CD plus DA. So, in the first step, we will do a construction, that is to say, we will draw perpendicular on AD at point P. Again, we will draw perpendicular on side AD of this quadrilateral ABCD at point P. So actually, this angle equals to 90 degrees in size, and this angle also equals to 90 degrees in size according to our construction. We'll extend the perpendicular from point P until it touches side BC of this quadrilateral ABCD. And we will define the touching point of the extended perpendicular from point P and BC this point as point M. Those two angles, they are both defined as one-sided interangles. The sum of those two one-sided interangles is of course equals to 180 degrees. And according to rule 18, whenever you have the sum of two one-sided interangles is equal to 180 degrees, then those two one-sided interangles must be located between parallel lines. That is to say, AB is parallel to PM. So repeat quickly on rule 18. According to rule 18, if the sum of two one-sided interangles is equal to 180 degrees, then they are located between parallel lines. In the drawing, we have those two angles, alpha and beta. They are both defined as one-sided interangles. If the sum of those two one-sided interangles is equal to 180 degrees, that is to say, if alpha plus beta equals to 90 degrees, then they are located between parallel lines. That is to say, line A is parallel to line B. So I can implement all 18 in our drawing. Welcome in our drawing. So as I mentioned before, the sum of those two one-sided interangles is equal to 180 degrees, and therefore they must be located between parallel lines. That is to say, AB is parallel to PM. So if you found out that according to rule 18, side AB is parallel to side PM, to line segment PM. Likewise, the sum of those two one-sided interrogations is also equal to 180 degrees, and therefore they must be located between parallel lines. That is to say, PM is parallel to DC according to Rule 18. So here PM is parallel to DC according to the same rule, Rule 18. Likewise, the sum of those two one-sided interrogations is also equal to 180 degrees, and therefore they must be located between parallel lines. That is to say, AB is parallel to DC. AB is parallel to DC according to Rule 18. So in total, we found out that all those three line segments AB, PM, and DC, they are parallel to each other according to Rule 18. So those three parallel lines, that is to say AB, PM, and DC, they are connected together by side AD, and they are also connected together by side BC. So here we can implement the basic proportionality theorem that talks about those two line segments AD and BC that connects the three parallels together. According to the basic proportionality theorem, the following relationship exists between side AD and side BC that connects those three parallels together by straight line. The following relationship exists between AD and BC. AP over PD equals to BM over MC. Repeat again. AP over PD equals to BM over MC. So until now, we found out that according to the basic proportionality theorem, the following relationship exists between side AD and side BC that connects the three parallels together. AP over PD equals to BM over MC. It is given us the question that AP equals to PD. So if we define the length of this side AP as x, then PD must be also equal to x because they are equal to each other according to what's given as the question. So repeat again, according to the basic proportionality theorem, the following relationship exists between AD and BC that connects the three parallels together. The relationship is AD, AP, AP over PD equals to BM over MC. AP is x, PD is also x, so AP over PD is x over x, and it is equals to BM over MC. BM over MC. So in total, we found out that according to the basic proportionality theorem, x over x equals to BM over MC. X over x is 1, so 1 equals to BM over MC. Here we will multiply this equation by MC, and finally we get that MC equals to BM. That is to say, this is line segment BM, this is equals to line segment MC. So it means that at point M, BC has been bisected into two halves. The first half of BC is BM, and it is of course equal to the second half of BC, that is MC, and each half must be equal to BC over 2 because BC is being bisected into two halves. So the knowledge found out that according to the basic proportionality theorem, BM equals to MC. Each half must be equal to BC over 2 because BC is bisected into two halves. And again, according to the basic proportionality theorem, we found out actually that BM equals to MC. The first half BM equals to the second half MC. Each half must be equal to BC over 2. But what is the value of BC according to what is given in the question? This is side BC equals in total to BQ, that is 10, plus QC, that is 40. So in total BC equals to 10 plus 40, that is 50. So BC equals to 10 plus 40, that is 50 over 2. 50 over 2 is 25. From this long equation, we will write that BM equals to MC equals to 25. BM equals to MC equals to 25. Okay, this is 97 BM, that equals to 25 units in its length. This is 97 MC, that is also equals to 25 units in its length. So just right now found out that BM equals to 25, BQ equals to 10. And therefore, let me say 97 QM must be equal to BM must BQ. So in total QM, this is the missing side QM, is equal to BM. BM is 25 minus BQ. BQ equals to 10 units in its length according to what is given in the question. So QM in total equals to 25 minus 10, that is 15. QM equals to 15 units in its length. In the next step, we will implement the Pythagoras theorem on this right green triangle, triangle PQM. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this right triangle QMP, here by PT is the evaluation for Pythagoras theorem. So in this right triangle QMP, according to the Pythagoras theorem, PM squared, that is the square of the hypotenuse, equals to QM squared plus QP squared. And again, according to the Pythagoras theorem, on this right triangle QPM, PM squared, that is the square of the hypotenuse, equals to QM squared plus QP squared. PM is the missing side, so we leave it as it is, so it is PM squared equals to QM squared. QM is 15, therefore QM squared is 15 squared, that is 225, plus QP squared. QP is 20, therefore QP squared is 20 squared, that is 400. So in total, we found out that PM squared equals to 225 plus 400. 225 plus 400 is 625. So in total we should find out that PM square equals to 625. So here we take a root out of this equation and finding out that the missing hypotenuse PM is equal to the square root of 625, that is 25. PM equals to 25 units in its length. This is the hypotenuse PM, and it equals to 25 units in its length. In the next step, we will do another construction, that is to say, from point M, we will do perpendicular on DC. Again, from point M, we will do perpendicular on DC. So actually, this angle equals to 90 degrees in its side, and this angle also equals to 90 degrees in its side, according to our construction. We define the touching point of the perpendicular from point M and DC. This point is point N. By doing this construction, we're going to do polynomial PM and D. Inside polynomial PM and D, we have 1, 2 Fourier angles. The sum of Fourier angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total must equal to 360 degrees. According to the rule, it says that the sum of the angles in any polynomial is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. And again, according to the rule, it says that the sum of the angles in any polynomial is equal to 360 degrees. So in polynomial PM and D, we have 4 angles. And therefore, we can relate to polynomial PM and D as a rectangle because it has 4 angles. If you know that the small polynomial PM and D is a rectangle in the next step, we define angle QPM. This angle is alpha. So in the green right angle PQM, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. This is side BC of quadrangle ABCD. So BC is the side of a quadrangle, it is absolutely a straight line. So if you focus on the left side of the straight line BC at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 states the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles you have at the left side of this straight line BC at point M, you have this angle is equal to 90 degrees minus alpha. This is the right angle, plus this first missing angle, in total must be equal to 180 degrees according to rule 3. 90 degrees minus alpha plus 90 degrees is 180 degrees minus alpha. So 180 degrees plus the size of this first missing angle, in total must be equal to 180 degrees according to rule 3. Therefore, this first missing angle must be equal to alpha. Because 180 degrees minus alpha plus alpha is 180 degrees. That is the sum of the angles on the left side of the straight line BC at point M according to rule 3. So this missing angle must be equal to alpha. So in this right triangle M and C, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha, according to the sum rule that states that the sum of the angles in any triangle is equal to 180 degrees. In the next step, we prove that those two right triangles can go into each other according to angle side angle rule. So why those two right angles can go into each other? This is to say we prove that this green right angle PQM can go into this lower right angle MNC. So why those two right angles can go into each other? First of all, those two angles are both equal to alpha and therefore they are equal to each other. In addition, those two hypotenuses, they are both equal to 25 units and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha and therefore they are equal to each other. So actually prove that those two right angles can go into each other according to angle side angle rule. That is to say, we actually prove that those two angles and the side that is included between those two angles, that is actually side PM, this great angle PQM are corresponding equal to those two angles, and the side that is included between those two angles, that is side MC, this right angle MNC. Therefore, we actually prove that those two right angles can go into each other according to angle side angle rule. So I write it down. We shall prove that the green right angle QPM congruent this is the sign of congruent to this right lower triangle MNC according to angle side angle rule. Again, we shall prove that the green right triangle QPM can point to the right lower triangle MNC according to angle side angle rule. And from the fact that those two right triangles can point to each other, we derive that those two sides must be also equal to each other in their lengths, according to the rule that states that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, and therefore those two corresponding sides must be also equal to each other in their lengths. So PQ equals to MN. But PQ is 20, and therefore MN must be also equal to 20 units in itself, according to the rule that I mentioned. Likewise, those two corresponding sides must be also equal to each other in their lengths. According to the same rule that says that corresponding sides in congruent triangles are equal to each other. This is side QM that equals to 15. And it must be equal to NC. But QM is 15, therefore NC must be also equal to 15 units in itself, according to the rule that I mentioned. We already found out that quadrilateral PM and D is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle PM and D, side PM must be equal to the opposite side ND. But PM is 25, therefore the opposite side DN must be also equal to 25 units in its length. Likewise, according to the same rule, in the same rectangle PM and D, side MN must be equal to the opposite side PD. But MN is 20, therefore the opposite side PD must be also equal to 20 units in its length. So PD equals to X and X equals to 20. AEP also equals to X. Therefore AEP must be also equal to 20 units in its length. So actually, we know that AD in total equals to 20 plus 20, that is 40. DC in total equals to 25 plus 15, that is 40. BC in total equals to 10 plus 40, that is 50. The only missing side is side AB. We find out the length of side AB by implementing the trapezoid mid-segment theorem on our quadrilateral ABCD. Quadrilateral ABCD is a trapezoid. Why quadrilateral ABCD is a trapezoid? First of all, the definition of a trapezoid. A trapezoid is a quadrilateral with one pair of parallel sides. In quadrilateral ABCD, we know that according to rule 18, AB is parallel to DC. AB is parallel to DC, and therefore quadrilateral ABCD is a trapezoid. Those two parallel sides AB and DC are defined as the bases of the trapezoid. The two other sides that are not parallel to each other, that is to say AD and BC, they are defined as the legs of this trapezoid, trapezoid ABCD. Okay? What is the definition of line segment PM? Line segment PM bisect AD. Why line segment MP bisect side AD? Because at point P is the midpoint of AD. This is to say the first half AP this is equals to 20, equals to the second half PD, this is also equals to 20. So line segment MP bisects the leg AD of trapezoid ABCD. Likewise, line segment PM also bisects the second leg of trapezoid ABCD. That is to say, line segment PM bisects the leg BC. At point M, BC has been bisected into two halves. The first half is BM, that is 25, and it is of course equals to the second half of BC, that is MC, that is also 25. So in conclusion, we can say that line segment PM bisects both legs. Line segment PM bisects the leg AD, and line segment PM bisects the leg BC. So therefore, line segment PM is defined as the mid-segment of trapezoid ABCD. Well, it bisects the two legs AD and BC. Actually, trapezoid mid-segment theorem is about the length of the mid-segment PM. What is the length of the mid-segment PM? The length of mid-segment PM equals to the sum of its two parallel bases, that is to say AB plus DC over 2. And again, the length of mid-segment PM that bisects the two legs AD and BC of trapezoid ABCD, it is equal to the sum of the two parallel sides of trapezoid ABCD, that is actually AB plus DC over 2. So maintenant, we found out that according to the mid-segment theorem, trapezoid mid-segment theorem, we only prove that quadrilateral ABCD is a trapezoid. So according to the trapezoid mid-segment theorem, the length of mid-segment PM is equal to the sum of the two parallel sides of trapezoid ABCD, that is actually AB plus DC, over 2. And again, if you found out that according to the mid-segment theorem, the length of mid-segment PM that bisects the two legs AD and BC is equal to the sum of its two parallel bases, that is actually AB plus DC over 2. So PM equals to AB plus DC over 2. But we already found out that PM equals to 25, so we can substitute PM by 25. And it is equals to AB. AB is the missing side, so we leave it as it is. So it is AB plus DC. DC in total equals to DN, that is 25, plus NC, that is 15. So DC in total equals to 25 plus 15, that is 40. Over 2. So in conclusion, we have found out that according to trapezoid mid-segment theorem, 25 equals to AB plus 40 over 2. Here we will multiply this equation by 2. And when we get that 2 times 25 is 50, so 50 equals to 40 plus AB. Here we subtract 40 from this equation. And when we get that the missing side AB is equal to 50 minus 40, that is 10. So AB equals to 10 units in its length. This is side AB of trapezoid ABCD, that is equals to 10 units in its length. And you know that the perimeter of this quadrilateral ABCD, that is actually trapezoid ABCD, equals to the sum of its four the sum of the four side lengths of this trapezoid ABCD. This is to say it is equal to AB, that is 10, plus AD, that is 40, 10 plus 40 is 50, plus DC, that is 40, so 50 plus 40 is 90, plus CB, that is 50, and 90 plus 50 is 140. So in total, we found out that the perimeter of this trapezoid ABCD is equal to 140 units in its length. So now we found out that the perimeter of this quadrilateral ABCD, the trapezoid ABCD, is equal to the sum of its four side lengths. That is to say, it is equal to AB plus AD plus DC plus CB. And again, the perimeter of quadrilateral ABCD is equal to the sum of its four side lengths. That is to say, it is AB plus AD plus DC plus CB. So it is equal to AB, that is 10, plus AD, that is 40, plus DC, that is also 40, plus CB, that is 50. So total, we found out that the perimeter of quadrilateral ABCD equals to 10 plus 40 plus 40 plus 50. 10 plus 40 is 50, and 50 plus 40 is 90. 90 plus 50 is 140. So the perimeter of quadrilateral ABCD, that is actually trapezoid ABCD, in total it is equal to 140 units in its length. And that is the answer to the question. Repeat again, the perimeter of this quadrilateral ABCD, in total it is equal to 140 units in its length. In the next step, I will present to you another way to find out the length of side AB is equal to 10. Here we found out that AB equals to 10 by implementing the trapezoid mid-segment theorem on our drawing. In the next step, we'll find out in another way that the length of side AB of trapezoid ABCD is equal to 10 units. So, in the second method, we do a construction, that is to say, from point B, we will draw perpendicular on PM. Again, from point B, we will draw perpendicular on PM. So actually, this again equals to 90 degrees inside, and this again also equals to 90 degrees inside according to our construction. We define the touching point of the perpendicular from point B and PM. This point is point S. By doing this construction, we created here the small quadrilateral ABSP. Inside the small quadrilateral ABSP, we have 1, 2, 3 arteries, and therefore this fourth missing angle must be also equal to 90 degrees inside, according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. So in quadrilateral ABSP we have 4 arteries, and therefore quadrilateral ABSP is a rectangle. In the next step, we'll focus on this upper right triangle, triangle BSM. In the right triangle BSM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, and therefore this front angle must be equal to alpha, according to the rule that says that the sum of the angles in the triangle is equal to 180 degrees. It is very easy to see from the drawing that those two right triangles can go into each other according to angle side angle rule. So why those two right triangles can go into each other? First of all, those two angles are both equal to alpha, and therefore they are equal to each other. In addition, those are the two hypotenuses of those two right triangles. They are both equal to 25 units in their lengths, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, and therefore they are equal to each other. So I should prove that those two right triangles can go into each other according to angle side angle rule. That is to say, we should prove that those two angles and the side that is included between those two angles, that is actually side BM on this side triangle BSM, are corresponding equal to those two angles, and the side that is included between those two angles, that is side MC, this right lower triangle MNC. And therefore those two right triangles can go into each other according to angle side angle rule. So I write it down. If you found out that this is the right triangle BSM, the upper right triangle BSM can point to this lower triangle MNC according to angle side angle rule. But again, if you found out that the upper right triangle BSM can point, this is the sign of can point, to the right lower triangle MNC according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive that those two sides must be also equal to each other in their lengths, according to the rule that I've already mentioned a couple of times, that corresponding sides in congruent triangles are equal to each other. Those two right triangles can go into each other, and therefore those two corresponding sides must be also equal to each other in their lengths. But NC is 15, and therefore the corresponding side SM must be also equal to 15 units in its length. What is the length of this missing 97 PS? From the drawing, it is very easy to say that PS in total equals to PM minus SM. So as you know, PS in total must be equal to PM minus SM. So PS in total is equal to PM, that is 25, minus SM, that is 15. So in total PS equals to 25 minus 15, that is 10. PS equals to 10 units in its length. This is the missing side PS. This equals to 10 units in its length. So in the rectangle, in this rectangle ABSP, side AB must be equal to the opposite side PS. But PS is 10, therefore the opposite side AB must be also equal to 10 units in its length. So we found out in the second method that AB must be equal to 10 units in its length. So the answer to the question is that the perimeter of this quadrangle ABCD in total it is equal to 140 units in its length. So we finished to answer the first question. In the next step, I will present you the second question and we will answer the second question of this lecture. In the second question, our task is to find out the area of this green shape. Begin again. This second question, our task is to find out the area of this green shape. So in the drawing we have two semicircles. This is the big semicircle with the diameter AB. This is the small semicircle that is located inside the big semicircle with the diameter PQ. Again, our task is to find out the area of this green shape. So we know that the diameter, so first of all we define the center of this big semicircle. This point is point O. And we define the center of this small semicircle. This point is point S. We define the radius of this small semicircle Sx. That is to say, the radius Sp equals to x. The radius Sq also equals to x. AB is the diameter of this big semicircle. AB in total equals to AC, that is 4, plus CQ, that is 6. That is 6. So in total, AB equals to 4 plus 6, that is 10. So the diameter AB of the big semicircle, in total it is equals to 4 plus 6, that is 10. Therefore, the radius of the big semicircle, capital R, must be equal to the diameter AB over 2. That is to say, it is 10 over 2, that is 5. So if you found out that the radius of the big semicircle is equal to 5 units in its length. The radius of this big semicircle equals to 5 units in its length. That is to say, OA equals to OB equals to 5 units. In the next step, we'll join points S and C together by a straight line. What is the definition of line segment SC? Line segment SC starts from point S, that is the point the center of this small semicircle, and that's at point C, that is the point of the small semicircle itself. So this is exactly the definition of a radius. Therefore, SC is the radius of this small semicircle, that equals to x. Point C is the point of tendency of tangent AB with this small semicircle. The radius SC is equals to x. The radius SC is drawn to point C. That is the point of tendency of tangent AB with this small semicircle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius CS. If AB is perpendicular to CS, it means that this angle equals to 90 degrees in its size. And this angle also equals to 90 degrees in its size according to rule 1. In the next step, we will do another construction. That is to say, from point P is the touching point between the small semicircle and the big semicircle. So from point P, we will do perpendicular on AB. Again, from point P, we will do perpendicular on AB. So actually, this angle equals to 90 degrees inside, and this angle also equals to 90 degrees inside, according to our construction. We define the touching point of the perpendicular from point P and side AB. This point is point M. What is the definition of line segment MP? MP is actually a tangent to the small semicircle point P. So MP is a tangent, and we have the radius SP is equals to x. The radius SP is drawn to point P, that is the point of tendency MP with this small semicircle. And whenever your radius is drawn to the point of tendency, then tangent MP will be perpendicular to the radius PS. If MP is perpendicular to PS, it means that this angle equals to 90 degrees inside, according to rule 1. So if you found out that inside the small quadrilateral PSCM we have 1, 2, 3 rectangles, and therefore this focus area must be equal to 90 degrees in its size. So in quadrilateral PSCM we have 4 rectangles, and therefore it is a rectangle. So it is known quadrilateral PSCM is a rectangle because it has 4 rectangles. But we also know that the opposite sides of a rectangle are equal to each other. So in the small rectangle PSCM, side SC must be equal to the opposite side PM. But SC is x, therefore the opposite side PM must be also equal to x units in its length. Likewise, according to the sum rule, in the sum rectangle PSCM, side PS must be equal to the opposite side MC. But PS is x, therefore the opposite side MC must be also equal to x units in its length. So we found out that the small quadrilateral PSCM is not a rectangle but a square, because of the fact that all of its sides are equal to each other. Each side equals to x. So the small quadrilateral PSCM is a square. What is the length of this missing 97 AM? From the drawing, it is very easy to see that AM this is the short 97 AM, that in total is equals to AC minus MC. Now, AM in total equals to AC minus MC. So AM in total equals to AC is 4, according to what is given as the question, minus MC. We just now found out that MC equals to x. So in total, AM equals to 4 minus x units in its length. So this is the short line segment AM is equals to 4 minus x units in its length. In the next step, we will do a construction, that is to say, we will complete the big semicircle to a circle. So I completed the big semicircle to a circle, and we'll extend tangent PM by a straight line until it touches the circle. We define the touching point of the extended tangent PM with this circle. This point is point N. MP is the tangent to the small semicircle at point P. So MP is a tangent, it is absolutely a straight line. When you extend a straight line by straight line, the result Pn is also a straight line. So if you focus on the right side of the straight line Pn at point M, here the sum of the areas must be equal to 180 degrees according to rule 3. Rule 3 states that the sum of the areas from one side of a straight line is equal to 180 degrees. So which areas we have at the right side of the straight line Pn at point M? We have this angle is equal to 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. So, in the drawing, point O is the center of the big circle. From point O, we have perpendicular OM on chord PN. Again, from point O, we have perpendicular OM on chord PN. And according to rule 15, whenever you have a perpendicular that is drawn from the center of the circle towards any chord, it will bisect the chord. Repeat quickly on rule 15. According to rule 15, the perpendicular from the center of a circle towards any chord bisect the chord. In the drawing, we have a circle. This is point S, that is the center of this circle. From the center of this circle, that is to say from point S, we have perpendicular ST on chord MN. And according to this rule 15, perpendicular ST bisects chord MN. If ST bisects chord MN, it means that the first half of MN is MT. It is definitely equal to the second half of MN, that is TN. And each half must be equal to Mn over 2 because Mn has been bisected. So according to rule 15, Mt equals to Tn equals to Mn over 2. So we can actually implement rule 15 in our drawing. One put in our drawing. From the center of this big circle, that is to say from point O, we have perpendicular OM on chord Pn. And according to rule 15, perpendicular OM bisects chord Pn. So Pn has been bisected into two halves. The first half of Pn is Pm, and this is definitely equals to the second half of Pn, that is Mn. Each half must be equal to Pn over 2 because Pn has been bisected into two halves. So I write it down. According to rule 15, perpendicular OM bisects chord Pn. So the first half of Pn is Pm, and it is of course equal to the second half of Pn, that is Mn. And again, according to rule 15, Pm equals to Mn, but we already found out that Pm equals to x. So we can write here that Pm equals to x. And from this equation, x equals to Pm equals to Mn, we will derive that Mn also equals to x. This is nice element Mn that is also equals to x units in its name. Mn equals to x. In the next step, we will implement rule 24 in our drawing. Repeat quickly on rule 24. Rule 24 is true in any circle, so in any circle if chord AB intersects with chord CD at point O, then the following equation is true. AO times BO equals to CO times DO. So in the drawing we have a circle. This is chord AB that intersects with chord CD at point O. Again, chord AB intersects with chord CD at point O. In this drawing, the following equation is true. That AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can implement rule 24 in our drawing. Why? Because in our drawing, we have this is chord AB. This is the diameter of the big circle. Chord AB intersects with chord PN at point M. Again, chord AB intersects with chord PN at point M. So it is on in our original drawing. We have chord AB that intersects with chord MN, chord PN, at point M. So all the requirements of rule 24 are satisfied, and therefore we can implement rule 24. According to rule 24, the following equation is true. That AM times MB equals to PM times MN. It again, according to rule 24, the following equation is true. AM times MB equals to PM over MN. AM is 4 minus X. Times MB. What is the value of MB? MB total equals to MC, that is X, plus CB, that is 6. So in total, MB equals to X plus 6 units in its length. And it is equals to PM times MN. PM equals to X, MN also equals to X. So PM times MN is X squared. So in total, we found out that according to rule 24, 4 minus X times X plus 6 equals to X squared. So here we will open the brackets of this on this side of the equation, and we get that 4 times X is 4X. Equals to 4 times 6 is 24, so it is plus 24. Minus X times X is minus X squared, and minus X times 6 is minus 6X, equals to X squared. So in this side of the equation we have 4X minus 6X is minus 2X, minus X squared, plus 24 equals to X squared. So here we will add X squared to this equation, and finally we get that here X squared will get cancelled. So in this side of the equation we have to leave with minus 2X plus 24 equals to X squared plus X squared is 2X squared. So here we will add 2x to this equation, and we get that 2x squared plus 2x equals to 24. And again, if you found out that 2x squared plus 2x equals to 24. So here we subtract 24 from this equation, and finally get the 2x squared plus 2x plus 24 equals to 0. Here we divide this equation by 2, and finally get that according to this equation, 2x squared over 2 is x squared, 2x over 2 is x, which is plus x, minus 12 over 2 is minus 12, equals to 0 over 2 is 0. So in total, we should find out that x squared plus x minus 12 equals to 0. So actually, this is a quadratic equation, and the general formula for a quadratic equation is as follows: ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. This is the general formula for x, or the value of x that is the variable that we are looking for. In our specific quadratic equation, that is to say ax squared plus x minus 12 equals to 0, the variable that we are looking for is x, and x is the radius of this small semicircle. X is the radius of the small semicircle. The coefficient A in our specific quadratic equation is equal to 1. The coefficient B also equals to 1. The coefficient C equals to minus 12. The only thing that is left to do is to put this data of our specific quadratic equation inside this general formula for x, and this way we find out the value of the values of x. We'll do it now, and you get that here we have x equals to minus b. B is 1, so minus 1 is, so minus b is minus 1, plus minus square root of b squared. B is 1, so b squared is 1 squared, it is 1, minus 4 times a times c. So a is 1, so minus 4 times 1 is minus 4 times c. C is minus 12, so minus 4 times minus 12 is plus 48. So total minus 4 times a times c equals plus 48. Inside the root we have 1 plus 48 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So total, if you found out that x equals to minus 1 plus minus 48 plus 1 is 49, and the square root of 49 is 7. divided by 2. So in total, we should found out that x equals to minus 1 plus minus 7 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 1 minus 7 over 2. So x equals to minus 1 minus 7. Minus 1 minus 7 is minus 8 over 2. Minus 8 over 2 is minus 4. So according to the first solution for x equals to minus 4. But x can never be equal to minus 4 because x is the radius of this small semicircle. So x is a length and x as a length must be a positive number. So it can never be equal to minus 4, that is a negative number. So we cancel the solution and we take into account only the second solution for x. The second solution for x is that x equals to minus 1 plus 7 over 2. Minus 1 plus 7 is 6 and 6 over 2 is 3. So the radius of the small semicircle x equals to 3 units in its length. The radius of this small semicircle x equals to 3 units in its length. Our task is to find out the area of this green shape. So what is the area of the green shape? From the drawing, it is very easy to see that the area of the green shape in total must be equal to the area of the big semicircle minus the area of this small semicircle. Okay, again, the area of the green shape in total must be equal to the area of the big semicircle with radius 5 minus the area of this small semicircle with radius radius 3. So the area of the big semicircle equals to pi r square over 2. R is 5, so it is pi times 5 square over 2 minus the area of the small semicircle. The area of the small semicircle equals to pi r square over 2. That is to say, it is pi times 3 square over 2. In the numerator of this expression we have 5 squared, that is 25, so in total in the numerator of this expression we have 25 pi over 2. Here we have 3 squared is 9, so in total in the numerator of this expression we have minus 9 pi over 2. So here we take 2 as a common factor out of those two expressions. So here we have 25 pi minus 9 pi is 16 pi. So in total the area of the green shape equals to 16 pi over 2, that is 8 pi. In terms of numbers is equals to 25 minus 1 3 is correct in size. So the area of this green shape in total is equal to either 8 pi squared in size, or in terms of numbers the area of this green shape is equal to 25.13 square in size. So we finish to answer on the second question. So in the next step I will summarize the lecture. We start with the repetition of the solution of the first question, and then we repeat on the solution of this second question. In the first question, our test is to find out the perimeter of this quadrigonal ABCD. That is to say, we have to find out the sum of its 4 side lengths. That is to say, we have to find out the value of AB plus AD plus DC plus CB. That is the perimeter of this quadrigonal ABCD. So in the drawing we have quadrigonal ABCD. Those 3 angles are all right angles. This is line 7BQ, that equals to 10 units in its length. This is line 7QC, that equals to 14 units in its length. This is line 7PQ, that equals to 20 units in its length. Again, our test is to find out the perimeter of this quadrigonal ABCD. So in the first step, we did the construction. That is to say, from point P, we go perpendicular on AD at point P. So this angle goes on 90 degrees, and this angle also goes on 90 degrees according to our construction. In the next step, we extended the perpendicular from point P until it touches side BC of quadrigonal ABCD. We define the touching point of the extended perpendicular from point P and BC. This point is point M. So those 2 angles now defined as one-sided interangles, and the sum of those 2 one-sided interangles is equal to 180 degrees, of course, and therefore they must be located between parallel lines according to Rule 18. That is to say, AB is parallel to PM. We figure on Rule 18, according to Rule 18, if the sum of 2 one-sided interangles is equal to 180 degrees, then they are located between parallel lines. In the drawing, you have those 2 angles alpha and beta that are defined as one-sided interangles. So if the sum of those 2 one-sided interangles is equal to 180 degrees, that is to say, if alpha plus beta equals to 180 degrees, then they are located between parallel lines. That is to say, line A is parallel to line B. So, can I implement Rule 18 in our drawing? We put in our drawing the sum of those 2 one-sided interangles is equal to 180 degrees, and therefore they must be located between parallel lines. That is to say, AB is parallel to PM according to Rule 18. AB is parallel to PM according to Rule 18. Likewise, the sum of those 2 one-sided interangles is equal to 180 degrees, and therefore they must be located between parallel lines. That is to say, PM is parallel to DC. Again, PM is parallel to DC. Likewise, the sum of those 2 one-sided interangles are also equal to 180 degrees, and therefore they must be located between parallel lines. That is to say, AB is parallel to DC. Okay? AB is parallel to DC. So in total, you should find out that all the three line segments A, B, P, M, and D, C are parallel to each other. So in the drawing we have side AD connects the three parallels together, and we have side BC, this also connects the three parallels together. Therefore, we can implement here basic proportionality theorem. According to basic proportionality theorem, whenever you have three or more line segments that are parallel to each other, and you also have two line segments that connect the parallels together, then the following equation will be true, that AP over PB equals to PM over MC. And again, going to the basic proportionality theorem, AP over PD equals to BM over MC. According to what is the equation, AP equals to PD. So if we define AP as X, then therefore PD also must be also equal to X. According to what is given in the question. So here we substitute AP by X and PD also by X. So AP over PD is X over X, that is equals to BM over MC. Here X over X is 1, so total if you found out that 1 equals to BM over MC. Here we multiply this equation by MC, and we found out that MC equals to BM. MC equals to BM. So actually, this is side MC equals to side BM. That is to say that point M is the midpoint of BC. Why point M is the midpoint of BC? Because at point M, BC has been bisected into two halves. The first half is BM, and it is of course equals to the second half, that is MC, and each half equals to BC over 2 because BC has been bisected into two halves. So if you don't know that BC has been bisected into two halves, the first half is BM, and it is of course equals to the second half MC. Each half must be equal to BC over 2 because BC has been bisected into two halves. BC in total equals to BQ that is 10 plus QC that is 40. So in total BC equals to 10 plus 40 that is 50. And then again BC in total equals to 10 plus 40 that is 50 divided by 2. 50 over 2 is 25. So in total if you found out from this long equation, we know that BM equals to MC equals to 25. So BM equals to 25 units in its time, MC also equals to 25 units in its time. On the left of this is line segment QM. QM equals to BM over BQ. Here QM equals to BM minus BQ. So QM equals to BM, that is 25, minus BQ, that is 10. So in total, MQ equals to 25 minus 10, that is 15. So in the next step, we presented the Pythagoras theorem. On this side, I have PQM. According to the Pythagoras theorem, in the right angle, the square of the hypotenuse equals to the sum of the squares of the perpendicular. So in the right angle PQM, it means that there is that PM square equals to QM square plus QP square. And again, according to the Pythagoras theorem, PM square, that is the square of the hypotenuse, equals to QM square plus QP square. PM is the missing side, so here it is. So PM square equals to QM square. QM is 15, therefore QM square is 15 squared, that is 425. plus QP squared. QP is 20, so QP squared 30 squared, that is 400. So in total, if you remember that PM squared equals to 225 plus 400, that is 625. So PM squared equals to 625. Here we took out of this equation, and found out that PM equals to the square root of 625, that is 25. Okay, this is the missing hypotenuse PM, that is equals to 25 units in its length. In the next step, we did another construction, that is to say, from point M, we look perpendicular on DC. Again, from point M, we look perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point M and the end. This point is point N. So in quadrangle PM and D, we have 1, 2 radius. The sum of radius is 270 degrees, so 270 degrees plus the size of this focus area, and total must be equal to 460 degrees according to the rule that the sum of the angles in any quadrangle is equal to 460 degrees. And therefore this focus area must be equal to 90 degrees inside. So in quadrangle PM and D, we have 4 rectangles, and therefore we relate quadrangle PM and D is a rectangle. So we have here rectangle PM and D. In the next step, we define the angle QPM. This angle is alpha, so in the angle PQM, this angle equals to alpha, this angle equals to 90 degrees, and therefore this focus area must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it equals to 180 degrees. It is the sum of the angles in a triangle. So this angle must be equal to 90 degrees minus alpha. BC is one side of quadrangle ABCD, and therefore it is absolutely a straight line. So if you focus on the left side of the straight line BC at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the right side of this left line, the straight line BC at point M, we have this angle is equal to 90 degrees minus alpha, this angle equals to alpha. Now, this first angle in total must be equal to 180 degrees according to rule 3. 90 degrees minus alpha plus alpha is 180 degrees minus alpha, so 180 degrees minus alpha plus this missing angle in total must be equal to 180 degrees according to rule 3. Therefore, this first missing angle must be equal to alpha. So in the right triangle M and C, this angle equals to alpha, this angle equals to 90 degrees, therefore this first angle must be equal to 90 degrees minus alpha according to the sum that says that the sum of the angles in a triangle is equal to 180 degrees. Actually, it's very easy to see that those two right triangles can go into each other according to angle side angle rule. So why those two right triangles can go into each other? First of all, those two angles are both equal to alpha, and therefore they're equal to each other. In addition, those two angles are both equal to 90 degrees minus alpha, therefore they're equal to each other. And finally, PM equals to MC. The hypotenuse of those two right triangles are both equal to 25, and therefore they're equal to each other. Therefore, those two right triangles can go into each other according to angle side angle rule. That is to say, I can prove that those two angles and the side that is included between those two angles, that is side PM, in this triangle PQM, are corresponding equal to those two angles, and the side that is included between those two angles, that is side MC, in this triangle AMC. And therefore those two triangles can go into each other according to angle side angle rule. And again, if you follow that the right triangle QPM can go into the right triangle MNC according to angle side angle rule. So we already found out that AB is parallel to PM is parallel to DC. Whenever you have 3 or more parallel lines that are connected together by underline segments, here those 3 parallel lines, AB, PM, and DC, the connected together by side AD, and they're also connected together by this side BC. And according to the basic according to the basic proportionality theorem, the following relationship exists between AD and BC that connects the three parallels together. The relationship is as follows: AP over PD equals to BM over MC. And again, according to the basic proportionality theorem, AP over PD equals to BM over MC. It is given as an equation that AP equals to PD. So if AP is X, then PD must be also equal to X because they are equal to each other according to what is given as the equation. So substitute AP by X and PD also by X. So X over X equals to BM over MC. X over X is 1, so in total we should find that 1 equals to BM over MC. If you multiply the equation by MC, we find out that MC equals to BM. So MC equals to BM. So point M is the midpoint of BC. Why? Because point M, BC has been bisected into two halves. The first half is BM, and it must be equal to the second half MC. Each half must be, of course, equal to BC over 2 because BC has been bisected. So repeat again. BM equals to MC, and each half must be equal to BC over 2. BC in total equals to 10 plus 40, that is 50, divided by 2. So BM equals to MC equals to 50 over 2, that is 25. From this equation, we know that BM equals to MC equals to 25. This is side BM, this is equals to 25 units in incident. This is side MC, this is also equals to 25 units in incident. What is the length of this missing measurement QM? QM in total must be equal to BM minus BQ. And again, QM equals to BM minus BQ. So QM in total equals to BM, that is 25, minus BQ, that is 10. So in total, QM equals to 25 minus 10, that is 15. This is measurement QM, is equals to 15 units in its length. So in the next step, we implemented the Pythagoras theorem on this n right angle PQM. According to the Pythagoras theorem, in n right angle, the square of the hypotenuse equals to the sum of the square of the perpendicular. So in the green triangle, it means that PM square equals to PQ square plus QM square. And again, according to Pythagoras theorem, PM square, that is the square of the hypotenuse, equals to QM square plus QP square. PM is the missing side, so leave it as it is, and it equals to QM square. QM is 15, therefore QM square is 15 square, that is 425, plus QP square. QP is 20, therefore QP square is 20 square, that is 400. So in total, we should know that PM square equals to 225 plus 400. 425 plus 400 is 625. So we should know that PM square equals to 625. Here we took out of the equation and found out that PM equals to the square root of 625, that is 25. So this is 97 PM is equals to 25 units in its length. In the next step, we define angle QPM. This angle is alpha. So in this green right angle PQM, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. According to the rule, it said that the sum of the angles in any triangle is equal to 180 degrees. BC is one side of quadrilateral ABCD, and therefore it is absolutely a straight line. So if you focus on the right side of the straight line, if you focus on the left side of the straight line BC at point M, here the sum of the angles must equal to 180 degrees according to rule of 3. So which angles you have the left side of the straight line BC at point M, you have 90 degrees minus alpha, plus 90 degrees, plus this first missing angle, total must equal to 180 degrees according to rule 3. And therefore, this third missing angle must be equal to alpha. Well, because 90 degrees minus alpha plus 90 degrees is 180 degrees minus alpha. And 180 degrees minus alpha plus alpha is 180 degrees. It is the sum of the angles of the left side of the straight line BC at point M, according to all three. So this missing angle must be equal to alpha. This side angle M and C. This angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must equal to 90 degrees minus alpha, according to the sum that said that the sum of the angles in any triangle is equal to 180 degrees. Therefore this first angle must equal to 90 degrees minus alpha. In the next step, we prove that those two right angles can join to each other according to angle side angle rules. If you prove that this is the green right angle PQM that is congruent to this right angle M and C according to angle side angle rules. So why those two right angles can join to each other? First of all, those two angles are both equal to alpha and therefore they are equal to each other. In addition, PM equals to MC, they are both equal to 25 units in their left and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha and therefore they are equal to each other. So I can prove that those two angles can join to each other according to angle side angle rule. That is to say, we can prove that those two angles and the side that is included between those two angles that is side PM in the green triangle PQM correspond equal to those two angles and the side that is included between those two angles in the side triangle MCN. Therefore, those two angles can join to each other according to angle side angle rules. The green right triangle QPM can join to the right small triangle can join to the lower right triangle MNC according to angle side angle rule. And from the fact that those two right triangles can join to each other, we derive that those two sides must also come to each other in their lengths, according to the rule that said that corresponding sides and congruent triangles are equal to each other. Those two triangles can join to each other, and therefore those two corresponding sides must be also equal to 90 degrees in their lengths. So, but PQ is 20, therefore MN must be also equal to 20. Likewise, those two sides must be also equal to each other in their lengths, according to the rule that said that the corresponding sides and congruent triangles are equal to each other. But side QM is 15 and therefore NC must be also equal to 15 units in its length. So DC in total equals to 25 plus 15, that is 40. AB is the missing side. PM, first of all, quadrilateral ABCD is a trapezoid because side AB is parallel to side DC according to rule 18. Side AB is parallel to side DC. Therefore, quadrilateral ABCD is a trapezoid. The two parallel bases, that is to say AB and DC, are defined as the bases of the trapezoid, and the two other the two other sides that are not parallel to each other, that is to say AD and BC, are defined as the legs of the trapezoid ABCD. So here we can implement trapezoid mid-segment rule. PM is the midpoint, point P is the midpoint of AD, and point M is the midpoint as BC. So And therefore PM is defined as the mid segment. Okay, and according to the trapezoid mid segment theorem, the length of the mid segment PM is equal to the sum of the two parallel sides of trapezoid ABCD. This is actually AB plus DC divided by 2. And again, according to the trapezoid mid segment theorem, PM, the mid segment PM equals to the sum of the two parallel bases of trapezoid ABCD. This is actually AB plus DC divided by 2. But we already found out that PM equals to 25, so we can substitute PM by 25. And this equals to AB. AB is the missing side, so we leave it as it is. Plus DC. DC is 40. So we found out that according to the trapezoid mid segment theorem, 25 equals to AB plus 40 over 2. Here we multiply this equation by 2. If I found out the 2 times 25 is 50, and it is equals to AB plus 40. So we multiply this equation by 2, and if you found out that 25 times 2 is 50, so 50 equals to 40 plus AB. Here we subtract 40 from the equation, if I found out that the missing side AB equals to 50 minus 40 instead, so AB equals to 10 units in itself. And therefore, the perimeter of this quadrilateral ABCD or trapezoid ABCD, in total is equals to AB plus AD plus DC plus CB, this is 140 units. And again, if you found out that the area of quadrilateral ABCD equals to 10 plus 40 plus 40 plus 50, this is 140 units in its length. In the next step, I presented to again the perimeter of this trapezoid ABCD, that is to say, the sum of its 4 side lengths, in total it is equal to 140 units in its length. The next step I presented to you, and that is the answer to the question. In the next step I presented to you another way to find out that AB equals to 10 units in its length. We did a construction, that is to say from point B we do perpendicular on PM. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. And define the touching point of the perpendicular from point B and PM, this point S. By doing this construction we can do quadrilateral BSP. Quadrilateral BSP we have 1, 2, 3 angles, 1, 2, 3 angles, and therefore this fourth angle has to equal to 90 degrees in size. According to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore this fourth angle has to equal to 90 degrees in size, and therefore quadrilateral AP PS is 4 degrees, and therefore it is a right angle. This right angle BSM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to alpha according to the sum of that said that the sum of the angles in any triangle is equal to 180 degrees. Okay. So, the next step we prove that those two right triangles can go into each other according to angle sine angle rule. So why those two right triangles can go into each other? First of all, those two angles are both equal to alpha and therefore they are equal to each other. In addition, the hypotenuse of those two right triangles, that is to say BM and MC, are both equal to 25 and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha and therefore they are equal to each other. So if you prove that those two right triangles can go into each other according to angle sine angle rule. When we find that those two right triangles can go into each other, we derive that the two corresponding sides, that is to say SM, is equal to the corresponding side NC. According to the rule that says that corresponding sides and congruent triangles are equal to each other. Those two right triangles congruent to each other, and therefore the two corresponding sides, that is to say ASM and NC, must be also equal to each other in their lengths. But NC is 15, and therefore the corresponding side SM must be also equal to 15 units in its length. In total, PS equals to PM also SM. Again, PS equals to PM also SM. So PS in total equals to PM, that is 25, minus PS, that is 15. And so in total, PS equals to 25 plus 15, that is 10. Okay, this is the missile side PS. This is equal to 10 units in its length. So in after again ABSP, side PS must be equal to double the side AB. But we just like now found out that PS equals to 10, and therefore AB must be also equal to 10 units in its length. So I presented two different methods to find out that AB equals to 10. And the answer to the question is that the perimeter of this quadrilateral ABCD is equal to 140 units in its length. So we finished to repeat on the first solution of the first question. In the next step, I repeat on the solution of the second question of this lecture. The second question of this was to find out the area of this vent shape. And the goal is very easy to say that the area of this vent shape in total must be equal to the area of the big semicircle or the area of the small semicircle. Okay. So the next step, we define the center of this small semicircle. This point is point S. We define the center of this big semicircle. This point is point O. We define the radius of this small semicircle Sx. So Sp equals to Sq equals to Sc equals to X. We know that AB, that is the diameter of this big semicircle, in total equals to AC, that is 4, plus CB, that is 6. So in total, AB equals to 10 units in its length. The diameter AB of this big semicircle equals to 10. Therefore, the radius of the big semicircle capital R must be equal to the diameter AB over 2. That is to say it must be equal to 10 over 2, that is 5. So if you found out that the radius of this big semicircle equals to 5 units in its length. In the next step, we need a construction, that is to say, we join points S and C together by straight line. Point S is the center of this small semicircle. Point C is the point of the small semicircle itself. Therefore, SC is the radius of this small semicircle that is equal to X. The radius of SC is equal to X. The radius of SC is drawn to point C, that is the point of tendency AB with this small semicircle. Whenever your radius is drawn to the point of tendency, then tangent AB will be perpendicular to the CS. If AB is perpendicular to CS, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to all one. In the next step, we did another construction. That is to say, from point P, that is the touching point between the big semicircle and the small semicircle, so from point P we go perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and AB. This point is point M. In the next step, we need another construction, that is to say, we completed this big semicircle to a circle, and then we extended this tangent PM. But before that, before the construction, we have here from point B with no perpendicular on AB. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. What is the definition of MP? MP is the tangent to the small semicircle at point P. The radius speed is equal to x, the radius speed is down to point P, that is the point of tendency of tangent MP with this small semicircle. Whenever radius is down to the point of tendency, then tangent MP will be perpendicular to the radius PS. If MP is perpendicular to PS, it means that this angle equals to 90 degrees according to all the rule that rule 1. So this is according to rule 1. So in total, in this quadrangle MPSC, we have 1, 2, 3 degrees, and therefore this 4 pieces must be equal to 90 degrees inside. So quadrangle PSCM is 4 degrees, and therefore quadrangle PSCM is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in the small rectangle PSCM, side SC must be equal to the opposite side PM. But SC is x, therefore the opposite side PM must be also equal to x units in its length. Likewise, according to the sum rule, in the same small rectangle PSCM, side PS must be equal to the opposite side MC. But PS is x, therefore the opposite side MC must be also equal to x units in its length. So we found out that quadrangle PSCM is not a rectangle but a square because of the fact that all of its sides are equal to each other. Each side equals to x. What is the length of this short line segment AM? AM in total equals to AC minus MC. So AM in total equals to AC, that is 4, minus MC, that is x. So in total, AM equals to 4 minus x units in its length. In the next step, we did a construction, that is to say, we completed this big semicircle to a circle, and then we extended tangent PM by side line until it touches the circle. We find the touching point of the extended tangent PM with this circle. This point is point N. PM is a tangent and therefore it is absolutely side line. When we extend the side line by side line, the result Pn must be also a side line. So Pn is a side line. So if we focus on the right side of the side line Pn at point M, here the sum of the angles must be equal to 180 degrees according to all three. All three said that the sum of the angles on one side of the side line is equal to 180 degrees. So which angles we have at the right side of the side line Pn at point M? We have this angle, this is the right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to 90 degrees in its size. So in the drawing, we have perpendicular OM on chord Pn. Point O is the center of this circle, so from the center of this big circle, we have perpendicular OM on chord Pn. And according to rule 15, whenever we have a perpendicular that is drawn from the center of the circle towards any chord, it will bisect the chord. Again, rule 15. According to rule 15, a perpendicular from the center of the circle towards any chord will bisect the chord. In the drawing, we have a circle. This is point S, it is the center of the circle. From point S, we have perpendicular ST on chord MN. And according to this rule 15, perpendicular ST bisects chord MN. That is to say, MT equals to TN, and each half must be equal to MN over 2 because MN has been bisected into two halves. So we can implement rule 15 in our drawing, right? Because in our drawing, from the center of this big circle, that is to say from point O, we have perpendicular OM on chord PN. And according to rule 15, perpendicular OM bisects chord PN. If OM bisects chord PN, it means that the first half PM must be equal to the second half MN, and each half must be equal to PN over 2 because PN has been bisected. So according to rule 15, the first half PM must be equal to the second half MN. So PM equals to MN, but PM equals to X. So you can write here that PM equals to X, and from this equation X equals to PM equals to MN, we will derive that MN must be also equal to X units in its length. This is the missing side MN, that is equals to X units in its length. So in the next step, we implemented all 24 in our drawing. So I click quickly on all 24. First of all 24 is drawn in any circle. In any circle, if chord AB intersects with chord CD at point O, then the following equation is true, that AO times BO equals to CO times DO. Again, in the one circle, this is chord AB that intersects with chord CD at point O. So in this drawing, the following equation is true, that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can definitely implement all 24 in our drawing. Why? Because in our drawing, we have this is chord AB, that is the diameter of the big semicircle. Chord AB intersects with chord PN at point M. Again, chord AB intersects with chord PN at point M. Again, in our drawing, we have chord AB that intersects with chord PN at point M. So all the requirements of all 24 are satisfied, and therefore we can implement all 24. According to all 24, the following equation is true, that AM times MB equals 2PM times MN. Again, AM times MB equals 2PM times MN. We already found out that AM equals to 4 minus X. AM equals to 4 minus X. MB in total equals to X plus 6. Again, MB in total equals to X plus 6. And it equals to PM, that is X, times MN, that is X. So in total, PM times MN is X squared. So in total, if you found out that 4 minus X times X plus 6 equals to X squared. We open the brackets of this expression and find out that 4 times X is 4X. And 4 times 6 is 24, so it is plus 24. And we have X times X times X is minus X times X is minus X squared. And we have minus X times 6 is minus 6X equals to X squared. So here we have 4X minus 6X is minus 2X, and we have here plus 24 minus X squared equals to X squared. Here we let X squared to the equation and find out that X squared plus X squared is 2X squared. Here X squared gets cancelled, and left only X squared plus minus 2X plus 24. So here we added 2x to this equation, and finally found out that that 2x squared plus 2x equals to 24. Here we subtract 24 from this equation, and finally found out that 2x squared plus 2x minus 24 equals to 0. Here we divided this equation by 2 and found out that 2x squared over 2 is x squared, 2x over 2 is 2x, and minus 24 over 2 is minus 2f equals to 0 over 2 is 0. So if you found out that x squared plus x minus 2f equals to 0. This is a quadratic equation, and the general formula for quadratic equation is as follows: ax squared plus bx plus c equals to 0. And this is the general formula. A, B, and C are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus 4 of b squared minus 4 times a times c over 2a. Now a specific quadratic equation, that is to say x squared plus x minus 12 equals to 0. The variable that we are looking for is x. X is the radius of the small semicircle. The coefficient a equals to 1, the coefficient b equals to also to 1, and the coefficient c equals to minus 12. The only thing that is left to do is to put the data of our specific quadratic equation inside this general formula for x, and this way we find out the value of the values of x, that is the radius of the small semicircle. We did it, and we found out that x equals to minus b. B is 1, so minus b is minus 1 plus minus square root of b squared. B is 1, so b squared is 1 squared, that is 1, and we have minus 4 times a times c. So it is minus 4 times a. A is 1, so minus 4 times 1 is minus 4 times c. C is minus 12, so minus 4 times minus 12 is plus 48. So in total inside the watch we're left only with 1 plus 48 divided by 2a. A is 1, so 2a, 2 times 1 that is 2. 48 plus 1 is 49, and the square root of 49 is 7. So here we have two solutions that are possible for x. X in total equals to minus 1 plus minus 7 over 2. The first solution for x is that x equals to minus 1 minus 7 over 2. Minus 1 minus 7 is minus 8, and minus 8 over 2 is minus 4. X is the length of this, the radius of this small semicircle. So x is a length. X is a length, it must be a positive number, therefore it can never be equal to minus 4, that is a negative number. So we cancel the solution and we take into account only the second solution for x. The second solution for x is x equals to minus 1 plus 7 over 2. Minus 1 plus 7 is 6, and 6 over 2 is 3. So we found out that the radius of this small semicircle equals to perimeter in its length. What is the area of this green shape? The area of the green shape equals to the area of the big semicircle plus the area of the small semicircle. So again, the area of the green shape in total equals to the area of the big semicircle plus the area of the small semicircle. The area of the big semicircle equals to pi r square over 2. R is 5, so it is pi times 5 square over 2, plus the area of the small semicircle with radius 3. The area of the small semicircle must be equal to pi times 3 square over 2. So it is minus pi times 3 square over 2. So here we have, in this expression in the numerator, we have 25 pi over 2, and here we have 3 square times pi is 9 pi over 2. And 25, here we took 2 as a common factor out of this, on those two expressions, and in total we found out that 25 pi minus 9 pi is 16 pi, 16 pi over 2 is 8 pi, in terms of numbers 8 pi equals to 25.13 square units in size. So in total we found out that the area that we were looking for this question, that is the area of this green shape, in total it is equal to either 8 pi square units in size, or in terms of numbers, the area of this green shape equals to 25.13 square units in its size. Okay, thank you very much.